Welcome. This video is going to look through 93202 NZQA Scholarship Calculus Examination from 2024. We're going to look at question 2 in this video. There's already a video up for question 1. So yeah, without further ado, we'll just move on to question 2 and have a look at the 3 parts to that question. The first part is this question here. It describes the maximum function for any two functions f and g defined on an interval a less than or equal to b, or less than x less than or equal to b. The maximum function is defined as the maximum of f and g is f of x if f of x is bigger than or equal to g, and g of x otherwise. In other words, when f of x is less than g of x. To demonstrate an example is shown, the maximum value function can be applied to more than two functions in a similar manner. And it says consider the function h of x, which is the maximum of 3 functions, 2 root x, 2x, and x squared on the interval from 0 to 3. And it says evaluate the definite integral on that same interval, 0 to 3, of h of x, this maximum function. So what we need to do for this is we need to determine for which intervals each function is the maximum. So if we started with a graph, just going to sketch here, doesn't have to be that accurate, but all these functions at x equals 0 start here. Maybe use 3 colors. So 2 root x, let's make 2 of these equal to 1. So 2 root x goes through 2, so it's a function, a square root function. Looks like this somehow. 2x, that looks like it's a straight line, and it goes through the same point. So this would be 1, 2, so it goes through that same point. And x squared doesn't go through that point, it goes through 0, 0 still, it goes through 1, 1, it goes through 2, 4, which would be here, which I think is actually where I should, yeah, this one here should go through that same point as well. So it's a quadratic. Now, so this one's y equals x squared, the blue one is y equals 2x, and the red one is y equals 2 root x. Now, as I said, this is a sketch, but we get fairly good data there. It looks like it 2 root x is going to be bigger than both of these other, the blue and the purple functions, provided x is less than or equal to 1. The linear function is going to be bigger than the quadratic, provided x is less than or equal to 2, and the quadratic is going to be bigger than both of the other two when x is bigger than 3. So we can actually establish that algebraically. So if we ask the question, when is 2 root x bigger than 2x? Now this is a quadratic in root x, so we could rearrange this. 2 root x squared, that's the left-hand side, minus 2 root x, shifting that over here, and then changing this round will be less than 0. And this will be 2 root x common factor times root x minus 1 is less than 0. Now this is a quadratic, goes through 0 and 1, and it's less than 0 between those roots. So we want root x, probably can format that a little bit better, 0 less than root x less than, don't need another square root, less than 1, which is the same as 0 less than x less than 1. So root x is bigger than 2x for that value. There's going to be 3 of these we need to investigate. When is 2 root x bigger than x squared? Well, if this was a quadratic, this is a quartic, so it's going to be root x to the power of 4 to get x squared, minus 2 root x is less than 0, and that's going to be root x as the common factor, root x cubed minus 2 is less than 0. And again, quartics are like quadratics. You might get a little wiggle in there somewhere, but when there's only 2 roots, the quartic is going to be less than 0 between those roots. So same thing, it goes through 0, and cube root of x equals 2, so I think that's going to be the cube root, x cubed, square root of x cubed equals 2, so take the cube root and then square, so we've got something that goes through these 2 points. There'll be some sort of point of inflection here, so we've got 0 less than cube root of x, or root x, less than the cube root of 4. Cube root of 2, when you square it you get 4. This is bigger than 1, so we've established that 2 root x is bigger between 0 and 1. And then the third inequality we want to look at is when is 2x bigger than x squared. Again, that's a quadratic, a more normal one, less than 0, x minus 2. So that's solved for x between 0 and 2. So just as we saw basically on our very, very rough sketch, we've got the square root function is the maximum up to 1. Between 1 and 2, the linear function is maximum, and above 2, the quadratic function is maximum. So that means that our integral, from 0 to 3, h of x dx, we can rewrite as the integral from 0 to 1, 2 root x dx, plus the integral from 1 to 2, 2x dx, plus the integral from 2 to 3, x squared dx. This is x to the half, add 1, you get x to the 3 over 2, divide by 3 over 2, same as multiplying by 2 over 3, so you'll get 4 over 3. That's evaluated at 0 and 1, plus x squared divided by 2, so you just get x squared evaluated at 2 and 1, and x cubed over 3 evaluated at 3 and 2. So putting 1 in, 1 to the power of 3 over 2 is 1, so we get 4 over 3 there. Put 0 in, you get 0, plus put 2 in, you get 4, 1 in, you get 1, 3 in, you get 27 over 3 is 9, 2 in, you get 8 over 3. So that is 4 minus 1 is 3, plus 9 is 12, and then it'll be minus 4 over 3, so that's 10 and 2/3, or 32 over 3. So that's part A. Part B it says given that the derivative is equal to 1 plus y squared, find the value of m for which the third derivative is equal to m times 1 plus y squared multiplied by 1 plus 3y squared. So the way to do this is just to calculate the second and third derivatives from this expression here. So if we differentiate it a second time, d2y by dx squared, differentiate 1, you get nothing. Differentiate y, we're differentiating, remember, with respect to x. So this is the derivative of this expression with respect to x. So you get 2y times dy by dx. And there's two ways to do this, and I'll do both of them. So you could just leave this like this, and then to find the third derivative, there's possibly more than two ways to do this. We differentiate this, but this is now a product. So when you differentiate a product, you write down one term and you differentiate the other, which will be the second derivative, and you differentiate the first term. Now we're differentiating, remember, again, we're still with respect to x, so we get 2, differentiate y, you get 1, but then times dy by dx, so you get 2 dy by dx, and then we multiply by the other term, dy by dx. And now we want to substitute in for this and these two terms here based on what we've got previously. So 2y, second derivative is another 2y times the first derivative, and plus this is 2 and this is the first derivative squared, so this is the 1 plus y squared. I could have put that in here as well, but I thought I'd do just one thing with each expression on each line. So this is 4y squared times 1 plus y squared plus 2 times 1 plus y squared. Now we've got common factor. This is a common factor, this is a common factor, and the 2 will be a common factor as well. So we can take a common factor of 2 times 1 plus y squared out. We're going to be left with 2y squared here, and over here we've taken out 2 and 1 plus y squared, there's another 1 plus y squared. So this is 1 plus y squared, and here we've got 1 plus 3y squared. And looking back at the question, this is exactly the form that we want the answer to be in, so our m is equal to 2. And I'm running out of power because I didn't notice that my power cable had come out. So we'll rectify that. As I said, you can do this a second way, and from this point here, and that is you could substitute in straight away. So let's do that. d2y by dx squared is equal to 2y times dy by dx is 1 plus y squared. Now you could use the product rule from there, but for differentiation purposes, for something as simple as this, it's going to be easier to multiply this out. So we get 2y plus 2y cubed. And then we want to find the third derivative. We differentiate this. So you get 2y goes to 1 times dy by dx plus 3 2's are 6 y squared, and then times dy by dx. Now this dy by dx is a common factor, as is the 2, but dy by dx is 1 plus y squared, which is one of the things we want up here. So we get 1 plus y squared, and then multiplied by, there's 1 here, and over here we get 2 3's are 6, which is exactly the form we want, and again we get therefore m is equal to 2. So this way is probably simpler, but I just illustrate that you can do the question either way or any other way that mathematically is sensible. Part 3, the last part we will look at today, part C, sorry, the third part, part C. We've got a function here that's the absolute value, and it defines the absolute value as the negative of x if x is less than 0, and it's just x if x is bigger than or equal to 0. That's nothing that should be unfamiliar to you. Excuse the double negative. This should be familiar, maybe not written in this form, but it's nothing special. It's just saying the absolute value of x is the same as x when x is positive, but we negate it if x is negative, and the negative of a negative will be a positive. In other words, you always get a positive. And it says consider the function s sub n of x, which is the absolute value of x take away 1 added to the absolute value of x take away 2 and continued adding all the way up to x take away n, with n bigger than 2, it says. And then it says find the derivative of s sub 3 at the point 5 over 2. I think it's going to be helpful for us to write out what this function is. So if we write out what s sub 3 is, s sub 3 evaluated at x, well, if all of these terms are positive, well, let's write it out firstly. I'm going to be squeezing here. I'll just go down just to make sure I'm not blocked out. If all of these terms inside the absolute values are positive, I should have put a 3 there, then you will get x minus 1 plus x minus 2 plus x minus 3, and that will be the case provided x is bigger than 3. And we could put equal to, bigger than or equal to 3. All of these terms will be positive. If we're between 2 and 3, then these two terms will be positive, but this one will be inside the absolute value will be negative, and so negating it, you'll get 3 minus x instead. So you get x minus 1 plus x minus 2 plus, instead of x minus 3, 3 minus x, and that's for 2 less than or equal to x less than 3. It doesn't really matter where you put the less than or equal to. We usually don't double count them, but you'll see that at the endpoints these things have the same value. Well, if at x equals 3, 3 minus 3 is 0, and 3 minus 3 is 0, so these two terms don't contribute anything, so you get basically the contribution from here. And similarly, if x is between 1 and 2, now this one's positive and these two inside are both negative, so that when we do the absolute value, we get the opposite. And that's for 1 less than or equal to x less than 2. And finally, if we're smaller than 1, then all of these terms will be negative inside the absolute value, so we have to negate them all. And that's for x less than 1. And we usually write a curly bracket around these, and maybe to make it look pretty, doesn't change the mathematics, put the equal sign somewhere else. So collating all that together, this is x plus x plus x, that's 3x, minus 1 minus 2 minus 3 is minus 6, and that's for x bigger than or equal to 3. And I put the equal sign in the wrong place again, so x plus x is 2x, minus x is just going to be x. Minus 1 minus 2 is minus 3, plus 3 is 0, so that's for 2 less than or equal to x less than 3. This one is x minus x is nothing, so we get negative x, and we get 3 and 2 is 5, minus 1 is 4, so we get 4 minus x. for 1 less than or equal to x less than 2. And finally here we get 1 plus 2 plus 3 is 6, and then minus 3x, x less than 1. So that's our function. Now from that we could differentiate. Now let's look at a picture first. We'll draw a little graph. What do I want to go up to? I don't think I need to go that high. 9 minus 6 is 3, so yeah, I'll just we'll use as much space as we've got, nearly as much space as we've got. So if x is bigger than or equal to 3, again I'll do these and use 2 squares for 1. X is bigger than or equal to 3. 3 3's are 9, minus 6 is 3, so it's going to go through this point here, and it's got a slope of 3, so across 1 up 3, so quite steep. If x is between 2 and 3, it's just got y equals x, which is just the line that goes through here. Maybe it will be easier to see if we change the colors. Between 1 and 2 it's 4 minus x, so 4's here, minus x is coming down like this, so we got this. And if x is less than 1 it's 6, which is up here, and minus 3x, so down to goes through there, so again quite steep. And I did say different colors, and I changed once and didn't do it again, so that will be blue, and this will be purple. So we've got, this is what the function looks like here, and the question asks us what's the derivative at 5 over 2, so this is 5 over 2, 2.5, what's the derivative here? And you can see from the picture that the derivative at 5 over 2 is going to be 1, the slope. We could differentiate these. It's going to be 3 when x is bigger than 3. It's going to be 1 between 2 and 3. It's going to be negative 1 between 1 and 2, and it's going to be negative 3 when x is less than 1. You don't need all that, but we're just differentiating piece by piece. Note that we lose the greater than or equal to and the less than or equal to symbols here, because at sharp points our function's not differentiable. So this function is only differentiable outside, or not including, these 3 sharp points. So we don't have any less than or equal to or greater than or equal to symbols in here. So yeah, that's straightforward. Probably did a little bit more than we need, but hopefully it will be useful, I think, for the next part of the question. This question, the second part, says what's the value of S of 2024, S sub to 2024 evaluated at X, find the minimum value of that and justify your answer. This sort of thing, partly the motivation for writing out more than I needed up here was so you could see what happened for S3, and I am going to propose to look at what happens for S4, and I think just from those 2 examples we'll see a pattern that we can generalize for other values of S, other values of the subscript, and we will be able to reason what the answer should be here, the minimum value. So S4 is the absolute value of x minus 1 plus the absolute value of x minus 2 plus the absolute value of x minus 3 plus the absolute value of x minus 4. You can write all these things out as I did before, but you can see that if all of these are positive, we just add them all up. So we get 4x 1, 2, 3, and 3, 6, and 4 is 10 minus 10 for x bigger than or equal to 4. We get 3x minus x, which will be 2x. That's minus 6 plus 4 will be minus 2 for 3 less than equal to x less than 4. Two of these will get x and x, and then minus x and minus x. So we will have minus, they will cancel. We have minus 1 minus 2 is minus 3 plus 3, so we'll just get 4 for 2 less than or equal to x less than 3. And this one will get x minus x, cancel, then we get minus 2x. Minus 1 plus 2 is 1, plus 3 is 4, plus 4 is 8. For 1 less than or equal to x less than 2. And then finally we're going to get minus 4x, and we'll get 10. So it's the first and the last are going to be symmetric here, x less than 1. So this is what we get. And if we drew a picture of that, again, and you don't have to do all of this, but I think it's going to help us. 1, 2, 3, 4. Now this one's easy. Between 2 and 3, the value is 4. Between 3 and 4, it's 2x minus 2. 2 3s are 6, minus 2 is 4, so that gets us to that point. And 2x, it's going to go up. To this value. 4x minus 10. 4 4s are 16, minus 10 is 6, which is this value. And we're going up in 4, 1, 2. So it's steeper here. Something like so. Over here, 8 minus 2x, so it's going down like this. 2 2s are 4, 8 minus 4 is 4, so that's right. And this one here, 10, so 5, 6, 7, 8, 9, 10 up here. And we go down, to these values like this. And you can see that in both cases, the minimum is exactly halfway. The minimum here, well, here it's on a range of values, but we're going from 1 to 4, the points where we extremes of the second term and the absolute values, and the minimum value is halfway between here. And I think you can see from this sort of construction that that's always going to be the case. We're going to start off for S 2024. We're going to start off with x minus 1 plus x minus 2 plus all the way up to plus x minus 2024. Each of these terms are going to be positive, so that's going to in turn be 2024 times x, and then minus some sum of I over I up to 2024. So the sum of the first I numbers. And similarly, you're going to see something happen to mine. Similarly, you're going to get x 1 minus x plus 2 minus x plus all the way up to 2024 minus x. So this is for x bigger than 2024, and you're going to get this one here, which is going to be this sum minus 2024 x's for x less than 1, and exactly halfway we will have the minimum. And that's because this exact halfway is going to have a gradient of 0. Everything to the right of that's going to have a positive gradient going away, and everything to the left of it has got a negative gradient, so it's coming down towards that point. So what is the value of S 2024 evaluated at x for 1012 less than or equal to x less than 1013? That's what we want to know, and that value is going to be x minus 1 plus x minus 2 plus ... plus x minus 1012, and then plus 1013 minus x plus 1014 minus x plus ... plus 2024 minus x. And there's 1012 terms here, and there's 1012 terms here. So these x's are all going to cancel out. And that means that this will be equal to the negative of the sum. Well, actually, it's better. I think it's easier to see if I write it out. It's going to be negative 1 minus 2 minus ... minus 1012. And then these ones will be plus, I'm going to write them underneath, plus 1013 plus 1014 plus ... plus 2024. And if I add these up pairwise, all of them equal 1012 plus 1012 plus ... plus 1012. How many are there? There's 1012 of them, so this is equal to 1012 all squared. And yeah, so this is S of 2024x, provided 1012 is less than or equal to x is less than 1013. Well, you could put it equals on there as well. And this is the minimum, because to the right we're going up, positive gradients. To the left we're coming down, negative gradients. In the middle here we've got a 0 gradient for all of the points between these. So this is a minimum. And that's the end of question 2. So any questions, put them in the comments. Otherwise, I'll see you next time with question 3. Thanks for watching. Good luck with your study. Push the wrong button.